Hi everyone. Today we're going to work on constructing the confidence interval for a unknown population standard deviation. So this is when you're actually taking a sample and you have all kinds of data and you find all your statistics and you want to estimate the population mean within the given confidence. And so we're going to be using the standard deviation created by your sample, not from a known source of the population. All right, so when we're doing this, when we're constructing the confidence interval for the mean, we're going to keep using that formula that we were given earlier. So we're still going to be doing x bar minus e less than mu less than x bar plus e. Now our e this time is going to be the t sub c, and it's going to be s over the square root of n. So we're going to have to go get our t confidence like we practiced the other day and use it in our e formula. Okay, so let's take a look at some steps here. All right, so we want to make sure the first thing is that we don't know the population standard deviation, that our sample is coming from a random sample, and either it is normally to begin with or our sample size is greater than 30. All right, so we're going to find our sample statistics, which means that we're going to be wanting to find x bar, s, and n. So make sure x bar, s, and n are things that we can find. So they may have been given to you in the problem, or you're going to be given a series of data and you're going to have to find that information. You're going to need to identify what your degrees of freedom are. So remember, degrees of freedom is sample size minus 1. You're going to need to find your critical values. Remember, that's going to be your t-chart. Okay, you're going to find your margin of error. So that's your e equals t sub c s over the square root of n. You're going to construct your interval. So that's going to be your x bar minus e less than mu less than x bar plus e. And then you're going to interpret your results. So the same sentence that we went over the other day is going to be what you're going to do. So you're going to write the sentence. Okay, so let's take a look at a problem. So we're going to randomly select 16 restaurants and measure the temperature of coffee sold at each. So we could be doing Dunkin's, Starbucks, McDonald's, Wendy's, Burger King, the diner, any place. And the sample mean of the temperatures is 162 degrees Fahrenheit with the sample standard deviation of 10. All right, so before we get into constructing our intervals, let's make sure we state our x bar, which is 162. Our s, which is 10, our n, which is 16, and let's find our degrees of freedom, which would be 16 minus 1, or 15. All right, so we're going to construct and interpret a 90% confidence interval for the mean, and then we're going to also interpret, don't forget the words interpret, we're going to have to write our sentence, and assume that the temperatures are approximately normally distributed. Okay, so we're going to assume that it's normal, which means our sample size does not need to be bigger than 30. All right, so let's go get our t sub c. Okay, so here's our chart. Oops, sorry. Okay, and we are doing a 90% confidence, and our degrees of freedom is 15. So our t sub c is 1.753. So let's find our e. So 1.753 s, which was 10 over the square root of 16. Okay, so do the computation, and I got 4.38. Okay, so we're going to add and subtract that to the mean. Okay, so we're going to do 162, so here's x bar minus e less than mu less than x bar plus e. Okay, so we're going to do 162 minus 4.38. We'll go 2 decimal places. All right, so our interval is 157.62 less than mu less than 0.38. All right, so let's write our sentence. We're going to say with a 90% level of confidence, you can say the population mean temperature of coffee sold at restaurants is between 157.62 degrees Fahrenheit and 166.38 degrees Fahrenheit. Okay? All right, so I'm not going to make you guys interpret the other ones, even though it does say to. It'll take a little bit more time than I have in my video time. So find and interpret. Okay? In the next one, for practice, I got a T sub C of 2.131. So our E would be 2.131, 10 over the square root of 16, or 5.33. Okay, so I'm going to end up with a confidence of 156.67, 167.33. Okay, and again, exactly the same thing, except the only thing we're going to change is the numbers. Okay, 99%. Okay, we're going to get an E or T sub C of 2.947, which means our E is 7.37. Okay, notice what's happening to your E as we're changing the level of confidence. As we expect to happen, is that level of confidence increases, so does the width of your confidence interval. Because we would need a bigger area, a bigger interval, think bigger thing on the number line to capture or estimate where the actual population mean would be. So this is 154.63 less than U, less than 169.37. Okay, so again, as we noticed, that it increases the width. What happens to your confidence interval as you increase your confidence is increase the width. All right, so I don't know about you, but I don't feel like going and looking at a T-chart, blah, 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 blah. Yes, our calculator does this. So let's do our calculator with this second group. All right, so we randomly select 36 cars of the same model that were sold at a car dealership and determine the number of days each car sat on the dealership's lot before it was sold. That's important information. The sample mean was 9.75 days, and the sample standard deviation was 2.39. So here we have an X bar of 9.75 and an S at 2.39. Okay. Again, we're going to do a 99% confidence for the population mean number of days the car sat on the car's dealership. All right, and our sample is 36. So that means our degrees of freedom is 35. All right, so I'm going to use the app that we looked at the other day. Okay. All right, so I'm going to go to Stat. I'm going to go to Tests. And I'm going to go T interval. All right, so we're going to start with our X bar, which was 9.75. Our S, which is 2.39. Our sample is 36. And why is this? Okay, so why did it, I don't understand why it did that. Oh, maybe I just didn't press enter. Yep, 36, enter. Our confidence is 0.99. Okay, so if you notice on the right and left, it says lower and upper. So there is my interval, 8.665 and 10.835. So we can write it 8.665 less than mu less than 10.835. And we would interpret that again. Let's practice right in our sentence. So with a 99% level of confidence, you can say that the population mean days that a car sat at the dealership lot is between 8.7 days and 10.8 days. Okay. All right, so let's try the next one using our app. Everything is going to stay the same, but now we're going to change our sea level to 90 and 95. So this sea level I'm going to change to 0.9. Press enter. Okay, so we went to 9.77 and 10.432. 423. Okay, so 90. And you can also write it using parentheses. We'll do the next one using parentheses. Okay, and then the 95%. Okay, it's 0.95. Make sure we press enter so it registers. So 0.894 and 10.558. Okay. I'll go 5.6. You can write them either way. Okay. And again, what happens as you change your width of the confidence, as it increases, our confidence interval increases. Okay, so now that we've talked about both, I think it's important to kind of look at when do we use what when, all right? When do you use a T, when do you use a Z? All right, so I have this little chart for us to hopefully help us out. Is your population normally distributed, or is n greater than 30? If the answer is no, you basically can't do the problem. You say, no solution, can't do, we're done. But the answer is yes. You're going to be able to do the problem. The question is it a Z or is it a T? So, is omega known? Okay, so in other words, do we have a population? So remember, this is population. Standard deviation. If the answer is yes, then you're going to use the Z. If the answer is no, then you're going to use the T with the degrees of freedom. Okay, so, question. You randomly select 25 newly constructed houses. The sample mean construction cost is $181,000. The population standard deviation is $28,000. Assuming construction costs are normally distributed, should you use the normal, the T, or neither to construct your 95% confidence interval for the mean? Explain why. Well, as you read through this, you're looking for words, you're looking for the standard deviation. Is the standard deviation a sample? Is it a population? Are they doing omega or are they doing S? And as you read through this, it says sample. Don't get stuck on the word sample mean. It's not the sample mean we care about. It's the standard deviation that we're interested in. So it says the construction is 181,000. The population standard deviation, that's the key. So that's going to tell us that we're going to use the normal or the Z. Okay? And again, why? Is because it says population standard deviation. We know that. We can use the Z. All right, let me know if you have any questions, guys. And remember that we're going to keep each other safe by staying in. And I'll talk to you again real soon.